Welcome to the first section of Unit A. We're going to talk about multi-step equations here. I do have a couple IXL sections that you can review if you need a refresher. Okay, so we're going to start with this first equation. You're going to distribute the 6. And the goal is variables on one side, constants on the other. So since the 18 and the 4 are on the same side, we add those together. Now I'm going to get rid of the 22. So we have negative, 35. Divide both sides by 6 to get the n by itself. And we're using improper fractions, okay? We're not using mixed numbers, not using decimals, so you're just gonna leave it as negative 35 over 6. All right, we have another one here. Notice you have x's on one side of the equal sign, so we can combine those. Negative 4x minus 3x is negative 7x. And then you wanna get the x alone, so we're gonna divide both sides by negative 7. That gives us negative 1. All right, this problem's a little bit more complicated because we have a fraction, but we're getting used to working with fractions here, and there's more than one way you can solve this. My advice to you would be to get rid of the fraction so everything is just a little bit cleaner to work with. So here, what I'm gonna do is I'm gonna multiply everything by 5 because that will get rid of the denominator over here. So on the right side, you'll just have negative 54 because the 5's cancel. If you multiply everything by 5, what happens is you're gonna multiply it by this 2 as well. So you're left with 10 times x minus 5. Do not multiply it by the x and the 5 because that would be double multiplying. So you only want to multiply it by the 2 because that's going to take care of distributing it into the x minus 5. You also could distribute the 2 in first and then multiply everything by 5 if you choose to do it that way. So a couple different paths you can take here. So now what I'm going to do is I'm going to distribute the 10. So I have 10x minus 50 equals negative 54. I'm going to add the 50 to both sides. So I get, 10x equals negative 4. And then I'm going to divide both sides by 10. So x equals negative 4 over 10. And our answer should always be in simplest form. So this can be reduced to negative 2/5 because 4 and 10 are both divisible by 2. All right, another multi-step equation here. See if you can figure it out. You could pause the video and try it on your own. I'm going to go ahead and distribute the negative 4, so the negative 8x comes down. Don't forget to take the minus in front of the 4 with it. So you have minus 16 minus 28x equals 40 minus 8x. Now I'm going to combine my like terms. So negative 8 and negative 28 gives me negative 36x. And then I want variables on one side and constants on the other. So I'm going to move the 36x over here, and I'm going to move the 40 over here. So that's negative 56 equals 28x. We're going to divide both sides by 28. And 56 is divisible by 28, so we get negative 2. All right, this one is definitely the spiciest we've seen so far. My advice to you, we definitely want to get rid of the fractions, but I think I'm going to distribute this first. If you choose to do it a different way, that's fine, but this will make things a little bit simpler down the road. So if I do that, my left side stays the same. And then when you multiply fractions, you multiply horizontally. So negative 5 times 7 is negative 35. And 2 times 4 is 8. So this is minus 35/8 x. And then that's going to be minus 5/2. All right, now what I'm going to do is I'm going to multiply the whole thing by the least common multiple, or the least common denominator. So you have a 16, a 4, an 8, and a 2. The smallest number that all of those can become is 16. So you're going to distribute the 16 through everything. So 16 and 3 is negative 48. The 16s will cancel here. So 7/4 x times 16. 16 divided by 4 is 4. And then 7 times 4 is 28. So this is 28x. You can use your calculator as well. 35 over 8. So 16 divided by 8 is 2. And then 35 times 2 is 70. So we have minus 70x. And then 16 divided by 2 is 8. 5 times 8 is 40. So this is a minus 40. I'm going to combine these two. 28 and negative 70 is negative 42. No, everything is a little bit nicer. I'm going to add 48x to the right side and add 40 to the left. So I'm going to bring this way. So when I do that, I'm left with negative 15. And when I bring 48 to the other side, I have 6. So then we'll divide both sides by 6. X equals 15 and 6 are both divisible by 3, so negative 5 halves is our final answer. All right, we got a few more to roll through. This one is tricky. When you have two parentheses that are next to each other that have a binomial or two terms inside, we do what we call FOIL. So that's first, outer, inner, last. So first, 3x times 2x is 6x squared. Outer, that's going to be minus 3x. Inner, minus 6x. And last would be plus 3. And we're going to do it on the other side too. So first is 6x squared. Outer is minus 12x. Inner plus 5x. And last is minus 10. So now really you want variables on one side, constants on the other. So if I subtract 6x squared to put it on the other side, you'll notice these will cancel. So now I'm just going to combine like terms. I have negative 9x plus 3 equals negative 7x minus 10. I'm going to add my 9x to the right side and add my 10 to the left. So I'm left with 13 equals 2x. So divide both sides by 2. X equals 13 over 2. All right, here we are going to distribute our 5. So negative 15 plus 40n, and then we'll distribute the negative 4 here. So a positive 40n minus 28, and then that plus 13 on the end. Oops, I forgot my n right here. 28 and 13, or negative 28 and 13 can be combined. What do you get? Negative 15. So you have 40n minus 15. And then if you move the 40n's, you'll actually see that they cancel. So you're left with negative 15 equals negative 15. And you might be left with different numbers depending on how you did this. But if that happens and all the variables go away, you just have to ask yourself, is this true? Does negative 15 equal negative 15? Well, it does. So we can conclude that it's infinite solutions. And you don't want to stop here. This is your answer, so you should actually write that out. All right, so see if you can figure this one out. We're going to distribute the negative and then distribute the negative again. Combine our like terms. So that's 2, and that's negative 12, right? And then we have negative 12r here. So I'm going to add 12r to both sides, so I end up getting 2 equals 0 because my 12r's cancel out. This is not true, so we can conclude no solution. Again, this is your answer, not this. All right, one final challenge problem, word problems. You're going to see lots of those. So it says it takes a graphic designer 1.5 hours to make 1 page of a website. Using new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. How many pages would the designer have to make in order to save time using the new software? So you want to define your variable first. So we're trying to figure out web pages here. So I'm going to let P equal pages. And that's the only thing we're trying to figure out. So we don't need an H for hours. You only need one variable. So really what I want to do is I want to create an algebraic expression for the old software and then the new software. So it takes a graphic designer 1.5 hours to make one page of a website using the old. So old is 1.5 per page. Per is always multiplication. So 1.5 times the amount of pages they use. The new software is 1.25 hours per page, so that's 1.25 P, but you need to put in an 8-hour shift of training. But you only need to do the training one time. So plus a solid 8, but that's not per page, it's just a simple 8 on its own. So how many web pages would the designer have to make in order to save time using the new software? So what you want to do is you want to find how many web pages it would be to break even. Okay, so like how many it would make it equal. So I'm going to set the old software equal to the new software. And I'm going to solve this. So if you subtract 1.25 from both sides, you get 0.25p equals 8. And then when you divide both sides by 0.25, you get 32. But here's the tricky thing. Is 32 the answer to the question? No. 32 pages is when it doesn't matter if you use the old or the new. It would take the same amount of time. So we need to make 33 pages in order for the new software to make sense, okay? So 33 and above will start saving us time, okay? So questions like this, you really have to think about the answer. Okay? So that's a wrap on multi-step equations. Hopefully you remember all of this. If not, let me know.